Hey guys, so this is your review for functions. So we talked about 4 different ways you can see a function that is written. So you can see it as a table, an x and y table. The mapping where x goes to y or input goes to output. The graph can literally be given, or they can give you ordered pairs or points in a list, a set. So what we're going to talk about is first, to be a function, one input must match exactly one output. That is what a functional relationship looks like, a one-to-one. So notice in the bottom here, I've given you a couple of examples of a function and things that are not functions. So I want to focus my attention on the parts that are not functions. So why this first list of points is not a function is because this -2 is my input, goes to 2 different outputs. So that is not functional. That -2 can go to 2 different outputs. Yikes. Another place where this is bad is in our table here. 4 goes to 2, but 4 also goes to +3. Which, guys, I can't go to 2 places at one time, right? Remember, every x must go to one y, all right? Now, according to the graph, if I look at this for this x value that I'm highlighting in yellow, I touch that graph not once, but twice. And that's not good. That means I have 2 outputs for that one input. That's bad. All right, and there's one last one with your mappings. You guys were really good with this. If you notice that one of those x's is going to multiple y's or outputs, that is also a trigger that this guy is not a function. So remember, a functional relationship is a one person to one person. So one input to one output only. All right, another thing you want to remember about functions is the notation. So the name of the function will be on the outside. Inside the parenthesis will be the input that they're looking for you to find or give, and then it will equal whatever the output is. So based on this example here on the far left, evaluate f of -2. Well, the first thing that I notice is that -2 is on the inside of the parenthesis. That means -2, oops, I shouldn't have done that. -2 is then the input. So I'm looking for the output. So in order to get that, I use the function, and in place of x, I put my input. And literally type that out. And we actually get an answer here. Now you can type that into Desmos if you want to get the answer. Or you can just do some math in your head. -2 times -2 is 4, and 4 plus 3 is 7, which means my output of f of -2 is 7. That is my output. Now, according to this next question, they give you a function of g of x, which is represented in the table. All right, so for letter A, it says, in the function of g, my input is -1. And my output from -1 is +3. And that is not true because -1 as an input goes to an output of 2. So I would not select letter A. G says that I don't know the input of G, but I do know the output is +2. So if my output is +2, it's claiming that those must have an input of -1 and +1, which is in fact truthful. Letter C says the function has one output for every one input. So does every input go to only one output? And the answer is yes, because -1 goes to 2, +3 goes to -1, 1 goes to 2, and -2 goes to 3. There is no repeating inputs. The last guy says the function of g has an input of 3, but it has an output of -1. So if I go to my input of +3, do I have an output of -1? is yes, I do. So B, C, and D were all truthful statements. The only one that was false was letter A. Now, another way you can also take a look at this, guys, is sometimes they'll give you the graph. And that's like this third one where it says, what is x if f of x equals -2? So if they give that to you, x is your input. I don't know what that is, but I do know that my output is -2. Now remember, outputs on a graph are the y value. So if I go down here to -2 on my y-axis, I'm going to follow it and I'm going to count how far to the right do I go before I actually touch that red line. So from 0, we went over 1, 2, 3, 4, 5, 6, 7, 8 units to the right is what it says. So my input is 8. So in order to have an output of -2 based on this function, I had to go to the right 8. So x is 8. All right, now what if I give you this function and I ask you find x when g of x is 8? Well, again, 8 is your output. We used to do this by hand by using the equation that's given, which you can do, but you don't want to go too crazy. Oh no, what did I do? Hang tight, guys. And you would solve for x by subtracting 5, and to undo dividing by 4, you'd multiply by 4. So you could end up getting your answer of 12 for x by hand, or guys, you can also use the power of Desmos. If you type in the equation 1 over 4x plus 5, you'll see the graph, and what you know is that your output is 8. So we'll come up to 8 on your y because that's the output, and you follow it until you touch the line, which means you're following how far to the right did I have to go before I got this output of 8. And the answer is to the right 12, which means x must be 12 when y is positive 8. Remember, every x has only one y partnership. Now, the next thing I want to recap with you is domain and range. Domain is how far left to how far right. So based on what we see in this function, the farthest most left I go is -4. We include it in a bracket. But to the right, I keep going out to the right and to the right and to the right infinitely. Parenthesis, because you can't touch infinity. Now, another way you can talk about it is you could say that your inputs, your x, your domain, must be -4 and anything bigger than or equal to -4. So that's two ways you can write that domain. Notice, guys, you will take into account that interval notation more than the inequality notation. But no, they can write it either way. Remember, range is how far down to how far up. So how low did we go? Did we go down low? And it looks like the lowest we go here is right here, which is at -3. So we'll start with a bracket at -3. Oh my goodness. And how high up do we go? Well, this function has an arrowhead, which means it keeps going up and up and up and up and up infinitely. Parenthesis, because you can't touch infinity. But you can also write the range as the y's, and you start at -3 as your lowest, and you continue upwards infinitely, which means I keep getting bigger and bigger and bigger, or greater than or equal to that amount. All right, if I give you a graph like this and I ask you to state the domain, remember you're looking at how far left to how far right. So I have a point at -1 from 0. I have a point at +1, a point at +2, and a point at 4. Remember, domain is left to right. If I want the range, I'm going to look how low did I go. So we went from -2 to +1, up to 3. Now you can also write this as a -2 there at the end, but it's not needed because you've already included it in your range. So you only have to include it once. Now the question is this guy a function? Does every x have only one y? I never touch more than once on every x. So that means this guy is in fact a functional relation. Last but not least, we'll talk about a set of weights. They have a 1-pound barbell, and you can add on 6 pair of weight plates. This is like bench pressing. Each pair of weights is 20 pounds. And so we're taking a look here. You can get the total weight of the barbell with those if we use this function of f. And they're asking you, what is the range of this situation? So one thing you want to think about is I can have 0 plates, 1 plate, 2 plates, 3 plates, 4 plates, 5 plates, or 6 pairs of plates that can be added on to our barbell. So this is what we call our domain. And so from those domains, we are trying to figure out what is our outputs, what is the range. So one way we can do this, guys, is use Desmos. And when we type in 20x plus 4 in Desmos, you'll see this graph. Now remember, your domain starts at 0, and why that is because you can't have negative numbers of weights. That doesn't make sense. So we're going to start here at 0, which starts at 4. So that's my first range. We can also keep going forward. So if I go to 1, let me zoom out here. If I go over to 1, I should be in here somewhere, which if I follow my line, oop, you guys saw it. It was at 24. Ooh, I keep missing it just by a little. There it is. So 1, 24. So what we noticed was our range at 0, it went to 4. At 1, it went to 24 as a range, and so on and so forth. So that means I can already nix out A and C as my answer choices, because at 0, they did not start at 4 like it was supposed to for the range, the y values, guys, the y's. And we said 0 goes to 4 and 1 goes to 24. So already we see that in this list right here, which means B must be our option. Time to practice your function review.